Hey everybody, I'm Dave Heber with the Aerospace Corporation. We are here at the International Astronautical Congress in Washington, D.C. Get ready for some Q&A with aerospace experts on some of today's biggest space policy questions. Hope you enjoy.
My name is Ed Swallow. I lead the efforts at Aerospace Corporation in the civil space area. It's important to make a distinction between a sustainable presence on the moon and a sustained presence on the moon. We need to understand how to work in microgravity, so we need some long-duration missions in preparation for going to Mars, but a sustained presence, a permanent presence on the surface of the moon is probably not affordable, especially since Mars is the end target. So a sustainable presence, one that's affordable for us to go back, to continue to use it as a proving ground, and then to go forward to Mars is the important point to be made.
I'm Karen Jones, and I'm with the Center for Space Policy and Strategy with the Aerospace Corporation. And I focus on strategy issues facing the commercial industry as well as national security space. Infrastructure in general is very important for the Arctic region, and certainly in a remote area such as the high north, latitudes well above the Arctic Circle, it's extremely remote, and satellite infrastructure can play a very strong role in closing the digital divide. Also, we've examined, with a recent paper that the Center for Space Policy and Strategy developed, we examined space infrastructure across three key capability areas. The first one being connectivity, the second one being remote sensing, and the third being navigation and positioning. All three of these capabilities are extremely important for operating in the Arctic region. The Arctic is changing at a fast, accelerated pace compared to the rest of the planet. It's warming at twice the rate of the rest of the planet, and the sea ice is melting. That is opening up many navigational routes, including the Northern Sea Passage as well as the Northwest Passage. This is increasing traffic to the entire region. So we can expect increased need for connectivity, navigation, and positioning. This is where space infrastructure can play a very strong role.
Hi, I'm Jim Vetta. I'm a senior policy analyst with the Center for Space Policy and Strategy at the Aerospace Corporation. I serve government customers and also do some of my own independent research, and one of the things that I've been looking into is space leadership, which has changed considerably since the Apollo program, back when there were just a very limited number of competitors in the space business. Nowadays, there are a lot of nations involved and a lot of independent organizations, companies that are involved in space, so it's a much more complicated scenario than it ever had been before. And at the same time, technology is proliferating very rapidly. Those are major factors that most people recognize in the space community as affecting how leadership will play out in the future. However, there's another aspect to look at as well. We are in the process of a transition from doing space operations that involve communications, navigation, other things that are involving signals going back and forth between the Earth and satellites, to a new plateau in which we are going to be manipulating objects on a regular basis. We're going to be doing on-orbit servicing. We're going to go to the moon and see if we can do resource excavation and processing. There are a lot of new activities that are going to require a new level of leadership. And that leadership can't be the old way we used to do it, by the numbers, where we said, who's got the most satellites? Who's got the biggest launch vehicle? Who's got the most firsts in space? Those are going to become less relevant than the notion of who is able to deliver on sustainable, enduring space infrastructure that allows us to do all of these value-added activities. Who is the most desirable partner for space collaborations in the future? These are the things that are going to drive the space leadership of the future and make it look a lot different than it did back in the days of the Cold War and the Apollo program.
So my name is Gina Galasso. I'm the Managing Director of the Aerospace Corporation UK. So as the Managing Director of the Aerospace Corporation UK, We are there to provide reach-back capability to aerospace back in the U.S. in a safe and systematic way. This is to enable freedom of action in the UK, in addition to protect sovereign capability. So Brexit is a disruptive event in the UK, and it's disruptive to the space industry, to the norm of the space industry. It is not the only thing that's being disrupted in the UK right now. It certainly is new space, globalization of space, commercialization of space. The UK has stood up a National Space Council as well. In the UK, the situation right now is extremely interesting and very exciting. So given everything that's going on right now, this is a wonderful opportunity for the UK to develop an integrated space strategy for the future.
Hello, my name is Jancy McPhee, and I have a PhD in neuroscience, and I am a research scientist at the Aerospace Corporation. And I am very interested in what we're going to actually do on the moon for our science operations, and how can we connect that to our needs and technology in order to enable that research. I also have a background in public engagement, so I'm happy to answer questions on either topic. So what matters to the public about our new moon mission, as opposed to what happened in the past with Apollo, is that the public's going to be very interested in the fact that we're not just going to go back to the moon, but instead we're actually going to be doing something that's going to require broader participation in space exploration, and we're going to have a large number of benefits that come back to the public. They're going to want to know exactly what we are going to do on the moon. How is it going to affect me? Will I be able to go to the moon? Will I be able to afford to go to the moon, or will there just be a few people going to the moon like back in the time of Apollo? Will I be able to have a job there? What sorts of new technologies are going to develop? Can I be a student and do experiments on the moon? Can I be a research scientist working remotely and working on the moon? That's where they're really going to be interested, is what are we doing as a larger group of people now in the future for our lunar exploration.
I'm Marlon Sorge. I'm a principal engineer at the Aerospace Corporation. I've been working on various aspects of space debris, from technical analysis to policy, for about 30 years now. The most important thing is getting rid of the satellites when you're done with them properly. Satellites are basically just a big bag of debris waiting to happen. And the longer you leave them up in space, the more likely they are to get hit, and the more likely you are to create hundreds, thousands, hundreds of thousands of pieces of debris, each one of which could then take out another satellite. So that has been one of the things we found, our European colleagues, the Japanese, everybody that's really looked at this as the absolutely critical thing that you have to do.
I'm Dave Eccles. I am the General Manager of the National Space Systems Engineering Division. I also serve as the Deputy Director of the Center for Space Policy and Strategy. There are many lessons that can be drawn from other industries that help us understand how we might do high volume production in space. Probably the first one that comes to mind is just the basic change from what we've been doing for years in the space business, which is manufacturing spacecraft, if you will, by hand, single projects. Probably the poster child for this is the James Webb Space Telescope. You know, it's enormous. It took years to build just that one very, very complex system. If you think about what happens, for example, in the automotive industry or in the aircraft industry, where they build hundreds or even thousands of the same kind of very complex system, there's lots of things that we can learn from that industry. 100 years ago, the automobile industry started building cars, right? They started doing it on an assembly line. Well, if you go from what's called project manufacturing, which is what we do for something like the James Webb Space Telescope, and you go to something which we call flow manufacturing, that's where you're building perhaps many per day. And all of the steps occur in sequence. There's a lot of things that occur in the automotive industry that we can translate to the space business. And that basic flow manufacturing is probably the first thing I would think of. Now, if you think about what you have to do in order to create a manufacturing facility that will allow you to build spacecraft in a flow approach, there's a lot of steps that you have to need to take up front. One of the lessons that we learned from the automobile industry, for example, is that they build prototypes. They initially build a prototype, they test it to the max. They may even test all of the different pieces of that automobile all the way to failure, so that they understand exactly how all of the different pieces will react. That allows them then to design the tooling, to develop the manufacturing flow, to do what we call design for production, which is sort of an assembly of all of the different tools and methods that have been used in the automotive industry or the aircraft industry or other high volume industries, and put them in a place where we can understand how they apply to the space industry.